Okay, we already know what effects the values of the coefficient A and the coefficient B have on the graph of a sine or a cosine function. What we want to look at next is what if there's some constant that's taken away from b times x within the function. And so you can kind of think about what we're looking at there as something that's being subtracted or possibly added to x. And if we think about what we know about transformations of functions, we know that's going to cause a horizontal shift either to the right or to the left. When we're dealing with sine curves, that horizontal shift is referred to as phase shift. Now, to know exactly how much shift you have to look at what's taken away from x, not what's taken away from b times x. So you first, if your equation is given to you the way that I have to put here, the first thing you have to do is factor out a b. Alright, phone rang. Where were we when I had to stop? I was factoring out a b. So factoring out b gives us x minus c over b. And that's going to determine how far to the right or to the left our curve has shifted. Same thing with our cosine function here. Got to factor out that b. And whatever number that is tells you shift. Remember that if it's negative, if x minus a number, you're shifting to the right, and if it's x plus a number, you're shifting to the left. So let's look at an example. If I have y equals 3 times the sine of the quantity 2x minus pi over 3, the first thing I've got to do before I worry with anything is I'm going to, whatever the coefficient of that x is, if it's something other than 1, I'm going to divide it out of that set of parentheses. I'm going to factor that out. So that would be 3 times the sine of 2 times the quantity x minus pi over 6. So now we know we have a function that has an amplitude of 3, a period of pi, and a shift to the right of pi over 6 units. So if we're going to sketch one complete period, normally the period would go from 0 to pi if the period is pi units long, and we would need the point halfway in between there at pi over 2, we'd need the point at pi over 4, and we'd need the point at 3 pi over 4. So I'm going to kind of try to keep myself organized on this unit circle. We'd have the point at 0, we'd have a point at pi over 2, we'd have a point at pi, and then we've chosen halfway in between there, which we know is pi over 4, and halfway between pi over 2 and pi, which we know is 3 pi over 4. But we need to shift all of these points to the right pi over 6 units. So to the right would be counterclockwise on the circle. So to go from 0 to the right pi over 6 units, let's use a red pen, will give us pi over 6. Okay, and pi over 6 is going to be just a little bit closer to pi over 4 than it is to 0. Notice pi over 6 is just a little bit closer to pi over 4 than it is to 0. The angle pi over 2, which is, well, no, I'll tell you what, let's go with pi. If we shift to the right, which is counterclockwise, pi over 6, that gives us the angle 7 pi over 6, and that's going to be our stopping point. Pi over 6 and 7 pi over 6. The other x-intercept would have been at pi over 2, but if that shifted to the right pi over 6 units, that's 2 pi over 3. So 2 pi over 3 would be about right there. Now, exactly halfway between pi over 6 and 2 pi over 3, in other words, if you take pi over 4 and shift it to the right pi over 6, that's actually not a special angle, so we're not going to mark it on our graph. We're just going to kind of estimate where that would be. So I know I'm going to have maximum values at 3, minimum values at -3. So just sort of eyeballing it to get halfway between pi over 6 and 2 pi over 3 would be about right there. Halfway between 2 pi over 3 and 7 pi over 6 would be about here. So I'm going to come down to -3. And then we'll sketch our sine wave. Let's do a cosine example. Y equals -3 over 2 times cosine of 2 pi x plus pi. Okay, 2 pi here is the coefficient of x. So that's what's going to get factored out. To begin with, that'll leave me x plus 1/2. So we have, in this case, reflection over the x-axis, a vertical stretch or an amplitude of 3/2. We have a period of 1. 2 pi divided by the coefficient 2 pi is 1. And then we've got a shift left 1/2 a unit. So if we're going to sketch one complete cycle or one complete period of this curve, now here's the cool thing. You're the one that gets to decide how the axes are labeled. All the other examples we've looked at so far, I've marked off the x-axis in terms of special angles. That doesn't really work for this particular problem. We've got a period of 1. So from 0 to 1 would be a complete cycle of this curve. So the important places as far as what we're thinking about there would be at 1/2, 1/4, and 3/4. I'd need to be able to show -1/2, -1.5 and +1.5 as maximum points and minimum points. All right, and then we've got to think about shifting this all to the left 1/2 a unit. So maybe here's -1/2, and then -1/4 is probably going to be important. Okay. Because of the reflection in the x-axis, instead of starting up on the maximum point, we're going to start down at a minimum point. So normally that minimum point would be on the y-axis, but it's shifted to the left 1/2 a unit. Okay, the end of the period would be 1, and we would be back down at that minimum point again. But because of the shift, that end of that first complete period is at 1/2. Then exactly halfway between the two minimums, we have to have a maximum, which is going to end up being on the y-axis this time. Exactly halfway between a minimum and a maximum, it's got to cross the x-axis. So we can put those 2 points on there. And then our cosine curve would look like that. And you can extend that further if you wanted to. But you only are required to show one complete cycle of this curve. If you did choose to extend it, you'd have another x-intercept at 3 pi over 4, another maximum at 1, And so this part of the curve would look kind of like that. You could keep going if you needed to. So again, thinking about labeling your axes, do what's convenient. Do what's going to make it easy for you to mark the important points on your sine or your cosine curve.